There we go. Welcome, Peter.
Welcome. How are you?
Very well. Good to see you again. Not been too long. But just to let you know, we are now in the live environment.
Excellent.
I'll make a quick introduction. If you can start sharing your slides, and I'll hang around until we get going. But for the purpose of the audience, the second session today will actually feature our event partner. You've already heard from Peter this morning. He represents Kelvin Inc. as their CEO. And he's going to share his thoughts on collaborative control, real solutions for real problems. So I will turn it over now to Peter. I can see your presentation on the first slide, which says Kelvin. So I will now leave the room, and I will hand it over to you.
Excellent. All right. Thanks, everybody. And I will get going. So first and foremost, I want to say I appreciate you being here. And today we're going to talk about something we discuss as collaborative control. And what does that mean, and why are we here is going to be a big part of this conversation. And so we started with a big problem, right? Based on our experience in working, frankly, with a number of different oil and gas customers, other industrial companies, we saw that there were a number of reasons why digital transformation initiatives failed. And we really started to ask ourselves why that is. And in fact, it built on some of the conversations that we just had in the opening panel, where we talked about a number of different dynamics. And it actually started in certain cases with people, where we saw challenges with inconsistent leadership, with, frankly, different people and different needs, and oftentimes a breakdown in terms of communication and collaboration. And so all of these were certainly like major impact, even though when we talk about digital transformation, there's a lot of focus on the technology. The truth is that it's also really about the people and understanding how people can work together more effectively. And in doing that, we also recognize there are very real technical challenges. So this isn't just, people. It is actually sort of an understanding that you need to be able to overcome the fact that there's a lot of legacy technology that's out there. There are challenges just based on the physics and the other sort of systems that are out there in the field that we work with. And as we are looking to embrace a number of the potentially more innovative and sort of opportunities for there to be real change, there are challenges. And so what we saw were, and these are just a few to sort of highlight, that there were real issues with the sort of the bridging between the operating technology or OT world and the IT sort of data environments that were out there. This is driven by the fact that in many cases, particularly in the oil and gas space, you're talking about distributed assets, you're talking about proprietary infrastructure and protocols. Sometimes these different systems have been brought together over the years through different acquisitions and otherwise. And what that leads to in certain cases is siloing and real issues in terms of OT and IT data sources not being unified. And you compound that with inconsistent sort of bandwidth connections and challenges with data access, just given the fact that wireless infrastructure isn't perfect necessarily across a number of these different environments. So you start with some basic challenges kind of on the kind of that OT to IT side. And then in addition, it becomes increasingly difficult, we found, to sort of actually develop applications that matter, that people can actually be able to use to drive results in their business. And this has to do in certain cases with different technologies that may not be aligned. It's very hard to take a machine learning model and necessarily run it on a 25-year-old RTU. But it's not just that. It's certainly in other cases where process experts, people who really understand how something works, aren't necessarily the most capable in terms of software development. And so what they possess in insight, they may lack in sort of code writing and capabilities. And in addition, it's not sufficient to just add a bunch of developers, because in many cases they lack the context and understanding of these processes. And so what that leads to is, again, inefficiencies and just complexity around application development. And it frankly doesn't stop there. There's also just the fact that even if you are successful in terms of small scale deployments, getting your application maybe working on a specific asset, maintaining that and keeping it going, particularly if you see people changes or underlying, sort of infrastructure changes, all of that becomes challenging. And And in addition, a lot of the machine learning work and the interesting sort of stuff that's coming forward, it takes caring and feeding. And if it doesn't get that, it will actually degrade over time. And so we see this as all being challenges, which can be exacerbated by the fact that in certain cases, asset operators may lack trust. They may not have a deep understanding of how this system works, and therefore how they can potentially interact with a new machine learning model or other technology, which ostensibly is there to help them, make their assets run more efficiently. But if they don't understand it and they lack trust, then they may very well turn that, application off. So we realized that there was a big opportunity here. And so our focus became around what can we do to solve these problems? And we really focused on this idea that it's a combination of collaboration ideas. It's collaboration across people. We started with this idea that we need to respect the individuals to understand their knowledge. And when we talk about sort of this context of control, it's recognizing that, there are cases where the control engineer, automation engineer, they're really the expert in, how this operating technology works. And so how do we utilize their knowledge? How do we make sure that their perspective is being valued? In addition, we've got incredible data scientists and domain experts who have great ideas and insights around how these systems can work more effectively, but not necessarily, they're not necessarily communicating on a day-to-day basis easily with those automation engineers. And lastly, you've got people who actually are responsible for the actual running of those assets, the owners themselves who are thinking about how do I maximize the efficiency of the system? How do I create the most value? And so it's a recognition that those are potentially three different constituencies, all of whom will have specific needs. So how do we empower those people? How do we upskill them? How do we give them the capabilities to be successful? In addition, it's not just people, it is actually sort of the ability to bring together the best information that's possible. And we think about collaboration of data sets where there may be data that's coming off of one antiquated system that you need to blend with something else to be able to make the best decision possible. And in addition, the goal is how am I maximizing the value of these machines? I've deployed, sort of machines to control these assets. How do I actually make sure that we're getting the maximum value out of that? With that goal being achieving sustainable impact. Like we're trying to do things that are going to be able to positively sort of move our business forward, not just on a short-term or a one-off basis, but something that will persist and something that will be sustained, and that impact we will see for a long period of time. So we really tried to address that in the context of our product and our solution. So we start with sort of how do we empower and upskill, our existing team. And we talk about leadership as being really critical to this, because part of this is that the leaders need to believe that things can, change for the better and be able to support the organization to do that. And then there needs to be fortitude around being able to stay that course and convince the organization. So that's a big piece of this, is understanding that it does need to be driven and that message needs to be consistent around the value of what you can do. And when you do that, you also need to be able to give the right people the right tools. And so for us, this is really a recognition that there's different groups that have different needs. And so to that end, what we've really focused on is the idea that first, you have to create a really strong connection between the existing operating technology infrastructure that may be there, in your system today, and the actual data and other sort of analysis that you're going to want to be able to do with that, So to that end, what we've really focused on is the idea that control engineers and automation engineers, they need to be able to quickly build and manage these bridges that can exist between their existing infrastructure and these new systems. And making a product that really sort of works with them and makes their life better is a critical piece of this. The second component is that once you've got that connection, once those connectors have been able to be put in place, you need to be able to create things easily. And in certain cases, that means working with domain experts who really understand how that process works around how to improve, a part of the system, be it through a logical-based model where you might have something that says, if this particular pressure goes above this particular range, I want to take the following action. And I want to be able to do that through an application, through software. I don't want to have to be the person who's constantly having to monitor and manage those things. I want to be able to do it in a way that's going to be scalable. And in addition, as we bring more and more sophisticated data science approaches and otherwise into the system, we want to be able to take those ideas and those more potentially complex models and be able to easily integrate those into the system. And so that's very much meeting your data scientists kind of where they are and allowing them to use their tools effectively to be able to push sort of change into your organization. And lastly, we need to make sure that we have this, we have the tools to be able to work at scale. It's not sufficient, we found, to be able to have real impact if you're just talking about 1 and 2 assets. You need to be able to think about, how am I going to impact across a whole field, across a whole system, and how am I going to do that in a way that my asset operators, my production engineers, and otherwise are going to feel like they have some element of control, that they have agency over this system. Because if they don't, their bias will likely be to say, I don't trust this and I don't want to necessarily use it. And so you lose then the benefits of this concept of collaborative control. So then how do we actually create sustainable solutions that have a real impact on our business? Well, for us, there's about impact itself. Like, how do you demonstrate impact? And what we've been able to show with a variety of different customers is that we're able to impact things like the production. So what does this look like in terms of being able to increase the amount of output in a particular gas field? There can be, in the case of our work with Halliburton, around understanding how we can help reduce sort of costs and efficiencies in their business. And with Schneider, we've been able to show how with their capability to be able to reduce the amount of energy that's being consumed. These are all situations where they have been able to use tools from a collaborative control perspective with Kelvin to be able to show real sustainable impact on their business. And so one of the things that we've recognized is you need to be able to break down the silos and really communicate and collaborate across your teams. And when you do that, you can also enable them to be able to create what we describe as control applications. And we're going to talk a little bit about what a control application looks like. So simply put, a control application acts as your best engineer on their best day. And so what this is really trying to do is to be able to take the process insights, the real understanding of how a system is working today versus potentially how it should work. And then based on inputs of information, what should be the response? Typically what we would find is, that could be done by a person who's seeing, observing changes in that system, watching sort of how the data might be changing, and be able to then sort of decide what to do, what action to take. What we've really done is said, if you can take that concept and you can go from an insight into an action, and if you can do that through software, you're going to create a lot of greater impact. Again, you're taking your best engineer on their best day, their ideas, their insights, and you're being able to then scale that potentially across a much broader part of your business. And so in this context, we divide a control application as really a model, and that can be a logic-based model in certain cases. It can be a much more complex data-driven model in others, to be able to really continuously detect kind of the process improvements and the events that might lead to a change. And then the second concept is the actor, which is based on that, whatever that model prediction might be, what is the action that gets to be taken? And how do we be able to use that to be able to safely and sustainably then improve the operations? And so this concept of control application is really the manifestation of those great ideas and insights that your engineers have today, captured into a form that can then be used across your broader operation. So what we've been able to do then is to back to this collaboration point. It's one thing to build an application, but in the case of a lot of the more modern machine learning, you also need to be able to build it and then sustain it and have it work in such a way that the people who are in the field are actually able to both make potential observations and even adjustments around how certain applications are working. Are they seeing kind of the same trend that the system is? Can they corroborate that? And what we've been able to do in this example with Schneider is to really build a bridge between some of the work that some of their data scientists have done around creating some interesting new models, and this is in particular from a beam pump application, and then be able to get the validation from the folks who are in the field, who are the production engineers who are working with this system. And that shows up in sort of this piece where you've got operators who are helping to train these machine learning models. So they may not be the person who developed it, but they're able to then observe where they see particular, dynacard shapes that are actually looking at how this potentially matches with other things. And so this is this wonderful blend of the practical knowledge of production engineers who are working with these assets, and the very more sort of data-driven approach of some of the folks who are coming up with these interesting new models. It's this ability to blend those two, which is a great example of the benefits of collaborative control. Both systems today, but both individuals today can really work to be able to improve the overall performance of these applications, and then the impact as that relates to the overall business. We've had, as I mentioned, sort of, a couple of just different, views on this, both in terms of, the work that we've been doing with Halliburton of late around how do we continue to help their organization innovate? How do we help them bring sort of a lot of the great insights that their team has to be able to positively impact some of their pressure pumping operations? And then concurrently, we've seen that with folks like Schneider, who are in the process of working with Kelvin to take a number of the different models that they've worked on to be able to then bring those to market, and to be able to then use, as I showed, some of the tools and such that really allow them to get to digital transformation and broader impact in terms of the organization. So what do we need to be successful in this context? And in our mind, what we can really help with is the ability to be able to simply and quickly deploy and manage advanced automation. This is to improve efficiency, this is to increase production, and this is to, at the end of the day, achieve sustainability. What we're finding today is that all of these different initiatives are related and critical. And if we go back to we just had some opportunity in the last session to talk about sort of how each of these relate together. And in the context of efficiency, we want to be able to think about, how do I take the best insights from our team today to be able to understand how do we make our operations run better? So you think about the world we are in terms of, coming through the last, 16 months in terms of COVID. There were a bunch of processes that didn't exist before then, which in terms of remote work, in terms of being able to improve performance of these assets, that can now be done that we really didn't necessarily believe were possible before. Those are examples of efficiency gains. And we want to be able to take those best ideas from your team and be in a position where you can then use them across as many parts of the organization as you choose. That's an important driver for this. Another example is just around production increase. And we have seen a number, at this point in time, multiple different types of applications that are running across, in this case, different types of artificial lift as an example, be it in terms of improvements in performance at beam pump, improvements in performance in terms of plunger lift, and other ways in which we sort of see production gains across the board. All of that is going to, have an impact in terms of, the overall revenues of these businesses, and that's critical. The last piece, though, and I think has become certainly incredibly important as it relates to the oil and gas market overall, is what are we doing in terms of sustainability? And it's just incredibly, important that we're thinking about what can we do to work through methane emission reductions? How do we, sort of see how our greenhouse gas sort of standards and otherwise, how we can honor them, how we can get to scope 1 objectives, let alone scope 2 and scope 3. All of those things we believe are part of a new opportunity for different types of control objectives. And what's important in this context is to recognize that sometimes those opportunities, are different than they were before. We weren't necessarily always focused on how do we minimize methane emissions, for example, while maximizing production. And that's something that we're really focused on being able to do and work with our partners on. And we've seen some tremendous results, coming out of some of our customers, where in certain cases we've seen venting reductions recently of, that are down 63% from where they were before. So this goal towards sustainability makes a huge difference, right, in terms of being able to achieve the broader goals for the market. So those are sort of some of the areas that at Kelvin we're really focused on being able to drive forward. And so when we think about what the future looks like, we want to make sure that we are very much a partner. We're viewed as somebody who can help work through some of the challenges which have happened in the past in terms of digital transformation. Because as I touched on in the beginning, we have worked directly with a number of the oil and gas customers who have embarked on digital transformation journeys and frankly may not have achieved all of the goals that they'd set out to. As we discussed, collaborative control, we believe, addresses many of those challenges. And it is very much around the Kelvin Intelligent Control products, which are really, sort of a reaction to our experience around where there have been challenges in the past. We want to be able to then work with the teams that, on our customer side who are trying to then be able to address some of these objectives. Empowerment of the team is critical. Getting your team to be more skilled, more confident, and more collaborative is a big part of driving success. The way that we get to the results around significant production increase, in the case of BP, they've published stats over 20% of production increase in certain fields. As we think about the work that we're doing with Halliburton, as we've seen sort of the success with Schneider, all of this is about empowering their team to be more successful. Each of those different organizations has great engineers, and it's about how do we then get them to be working at their best. We're in a position where our system is designed to be able to make that happen and to be able to then integrate with the existing digital initiatives that are already in place. So we want to be able to help work through that and to get to the results of greater sustainability in the end, because we know that it's sustainability in the context of these businesses that's going to drive the long-term results. So let me see if that's a quick summary in terms of, all right. So that's what we're covering in terms of today. Do I have any questions at this point in time? Yeah.
Hi, Peter. Hey. Do you want to stop sharing if you stop sharing your presentation, then we'll appear a little bit bigger on the screen. And we have a couple of questions. So if the screen share probably wouldn't allow you to see the Q&A functionality. So just a reminder to everyone, we do have time for Q&A. So to the audience that is listening, please drop your Q&A in the Q&A box. If you look on the right-hand side, there's a cleverly titled Q&A. So just simply drop your information in there, and we'll ask those questions. So Peter, do you want me to read the questions? Or
I can see that. I got the first question, it looks like from Marcus Lim. So I'll answer that. So Marcus, what we did was we worked directly with BPX to be able to integrate basically across one of their large oil and gas fields. In this case, it was in Wamsutter, to be able to take a series of different control applications that were very much kind of a machine learning driven scheduling program to be able to improve the production of this entire field. And in this case, what they were running into were issues where they had a series of different plunger wells that were had concurrent arrival issues. And by working through and scheduling that and basically being able to build these models that would be, applied at scale, it dramatically changed the amount of it reduced the number of these concurrent arrivals, which were leading to challenges where the wells were actually having to be shut in and eventually vented. And so by addressing that, what it allowed us to do was to see this significant, this 22%, increase in production. And they were obviously very excited about that. There was also, what we didn't highlight was a 74% reduction in methane emissions. And so that combination was so powerful for BP. They actually, not only they put it into their, to an earnings release in Q4 a couple of years ago, and they then went on to talk about it, with Forbes around some of the initiatives, some of the real success cases around digital transformation. And so it was very much, again, the application of a model that had been developed by some of the data scientists, with integration with the number of the control engineers who really understood sort of how those systems were working, and then a lot of buy-in from the actual production engineers and the folks who were working on the field. And it's that combination that led to those results.
Perfect, thank you. Do we have any other questions from the audience? If you just drop them in the Q&A box, we have a couple of minutes. Unless there's any final thoughts from you, Peter?
Just that we're very much sort of enjoying, spending time with customers who are trying to think about very digestible sort of digital transformation initiatives. I think one of the things that came up in the earlier conversation, which we've seen a lot of as well, which is it doesn't have to fully be this massive monolithic change to start to show impact. Our approach has been, let's create more bite-sized chunks, which allow you to be able to take on a certain project, get buy-in from a smaller number of people, and show results. It's really critical to be able to build this up in stages. And as you then show that success, then you're able to talk about, okay, what about this expansion opportunity and that expansion opportunity as we go? One of our customers, that we've been working with for the last couple of years, for example, they started with some very simple, Kelvin applications related to some of their existing gas wells. The success on that in terms of the performance improvement was significant, and we saw return on investment of over 8x. And then on top of that, they said, well, if you've been successful here, can you help us, for example, with this venting problem that we're having? And so we worked on that together with them. They had some great ideas, and we were able to turn that into an application that, as I mentioned earlier, had a 63% reduction in methane for them. And based on that success, now we're in the process of moving across a completely different sort of field with them, much higher value, much more potential impact. But again, it's based on sort of the success we've had in the past and building that confidence and growing that going forward. And so we're very excited about being able to find ways in which we're able to sort of make those incremental gains to build that confidence to be able to go forward. Let's see.
So we just had I think we've got a final question for the purpose of the time. So would you like me to read the question out? Or?
Yeah, that'd be great.
So this is the digital bridge very much needed of wanting to do digital versus doing digital. So I think it's more of a comment rather than
more of a comment. Yeah, and I think that's right. So not everybody on the call may be as familiar with sort of the challenges of integrating between the IT and OT worlds. But I can tell you that the operating technology out there, the data is not necessarily consistent. It's not always available, and it lacks context in a lot of cases. And so what that means is it becomes, frankly, quite challenging to work with versus maybe what we've grown accustomed to with a really well-curated data set that sits in the cloud. Like, the real world is messier, it's dirtier, it's more dangerous. It has challenges around sort of the integration of these new technologies. And so our approach has been, can we create bridges that provide context, that provide a robust connection, and that also have sort of, make that available in such a way that it will be useful for both the creation of new applications, but then the running of these applications that can go successfully over time. Because as we mentioned, it's one thing to get something implemented, it's another thing to keep it working sustainably. And it's really only in that kind of that sustaining something at scale, that you maintain, that you achieve like real impact on the business. And so that's the piece why connection layer and building that bridge is so critical to the long-term success of these initiatives.
Perfect. Thank you very much, Peter. So I think that brings the session to a close. So thank you very much for sharing your insights. Really appreciate it. Great to see we've had a few questions come through. So before we take a move on to the next session, just a quick reminder. I've already mentioned this to everyone, but there is a virtual exhibition as well. So Kelvin have a virtual booth. You can go into the virtual booth. You can meet with Peter. You can meet with the Kelvin team. You can ask more direct questions. They've got various handouts where you can take and you can view at your own leisure. So do feel free to visit their booth. You can also schedule a meeting in there as well. So if you want to meet with them later on, you can actually have some FaceTime, meet face to face, just like we are now. So
Great.
I do encourage you to do that. Otherwise, once again, thank you very much, Peter. Really appreciate everything from this morning, and we hope to see more of you.
All right. Thank you. And look forward to seeing folks at the booth. Take care.
Take care. Thank you.